G'day guys, Andrew from On Track. Well, today I'm here with Riely from JU Designs. We've been working with these guys for a number of years now, with obviously our Y62 projects and GVM upgrades and stuff like that. We've been slowly expanding that range of what we're doing with our GVMs, and today here, Riely's here collecting some more data on some of the vehicles that we've tested previously. And yeah, Riely, what are you exactly doing?
So today, what we're looking to do is a part of developing the on-track GVM kits for the American vehicles is we need to validate that the axle capacities are going to be okay at those uprated loads. So what we're doing is taking a 3D scan of the whole rear diff and suspension, and then we'll turn that scan into CAD data and conduct FEA on it, and then we can understand if it's going to be okay at the upgraded GVMs and axle capacities or whether we need to do further modifications.
So obviously from the testing that we did on the track days,
yes,
that we did last year, to now, obviously you'll be able to put everything together and then tell me what's going to fail, hopefully.
Yeah, exactly, and then we can put that to both state and federal authorities to go, here's how it's compliant with all the ADRs, we know it's fine for braking, we know it's fine for general safety requirements, and then we also know that we'll know where the weak points of the systems are and we know what we can play with from there.
Yeah, right. Well, I mean, I think at the end of the day, that's all going to determine on what our final figure is that we sort of outcome for the GVM upgrades that we're doing, you know. So I think it's very important to know, and that way we will put our spin on things and say, all right, well, you know, I think this is only capable for this, or let's go higher.
Yep. Yeah, you always have to account for margins of safety and the intended use of the vehicle and all that sort of stuff as well. So.
Yeah. So I think we've got to play a lot of common sense in that regards. You know, I mean, the last thing, you're not putting 4.5 tonne behind this thing constantly, you know, so it's one of those things.
Everything's a compromise, isn't it?
You have to.
So.
You have to. So, all right, well, I'm going to let you do your thing and do a little bit of scanning, and we're just going to float around and have a look.
We're using the Peel 3D scanner. This is an optical scanner that is pretty good mid-level for what we're doing for reverse engineering aspects. You can get higher and lower models depending on what you need to do, but for what we do with consulting mechanical engineering, this is pretty spot on. So again, we will capture as much data as we can from the rear of the vehicle. We get that in a point cloud format, and then we'll take that back to the office and turn it into meaningful CAD that we can do FEA or finite element analysis on. And then ultimately, Andrew and On Track can use that data to then develop any products or accessories that need to be put onto the rear of the suspension. So.
Definitely, the scanner's generally making life a lot easier in today's world than what we're seeing than what we used to do a number of years ago, where we were just like, let's stick a bit of metal here and stick a bit of metal there and go and test it.
Tape measures and drawing pads, absolutely.
Yeah.
The other advantage with 3D scanning is that you can go straight to 3D printing, so you can do a lot of prototyping overnight with plastics and you don't have to go straight to the machine shops or get out the welders and grinders and as much as once you had to. So
definitely less labour intensive in that regard.
Yeah, absolutely.
So.
How it works is it basically bounces light off the object. So two of the lenses will produce that shuttering light, and then one of the other lenses captures it. So kind of just like a camera, really. But yeah, being optical, it's really dependent on light and shadow. So some of the laser models are less worried about lighting. You can do them in full light and they're a lot better with shiny and reflective objects, but
So that will explain in some cases where we've had objects scanned, Riely, that the components will come back white. I dare say that the guys who are doing the scanning are obviously putting some sort of film or product on it to make it less shiny.
Yeah, exactly. There's a whole host of products that you can use to improve an optical scanner. So one of them is a fine powder that gets sold with the scanner. And similarly, tracking dots, they're really valuable when you're scanning something that doesn't have a lot of like asymmetrical detail, like body panels and well, the fuel tank, for example, because the scanner would lose its position and not have a reference location. Whereas something like this, we got a lot of unique geometry. It's really quite good to scan. So
it's definitely showing up on the computer with a lot of detail in what you're actually putting it over and building.
Yeah. Like I was saying before, you can even read a lot of the casting part numbers from the diffs and the brake calipers and uprights, so it's pretty cool.
Definitely something we'll look into getting in our hands. I mean, we've been playing with a 3D printer for the last 4 or 5 months now that we've purchased for the shop, and obviously that's the next addition to the puzzle that needs to happen for us.
Yeah.
And look, and even if that's the case, it saves you guys coming down, and I can just send you a file and off you go.
Yeah, exactly. So, and similarly, we use this with a lot of our mechanical engineering, reverse engineering design. If someone needs something load rated or analysed, sometimes rather than drawing up a tow bar for your prime mover truck, you scan it and put it straight into the computer, and then you can do it that way.
Yep. So it will allow us, if we wanted to, scan a product and then grab another product from somewhere. If we scan another product, drag it onto it, and then obviously model it, stick it up where it needs to be, and all that sort of stuff.
Yeah, you can scan multiple sections of a vehicle, stitch together different components.
Yep.
You can build the whole thing on the PC if need be.
Yep. Yeah. Okay. Well, it's technology, isn't it?
Yeah, it's good.
Well, Riley, that all looks really good. It looks like it's going to be fantastic once you've modelled all that with all our GVM data from the racetrack, obviously, and all the braking tests and all that sort of stuff. So, yeah, definitely going to be really good to see when that all comes out, and where we've put all that sort of stuff and how we assemble it all as part of our GVM kits. For engineering, vehicle, obviously, GVM upgrades and all that sort of stuff. Look, the guys at JU, they're located up in Ballarat. Really good to deal with. Obviously, as you know, we've been dealing with them for quite a number of years now, so we're really happy with them, and yeah, really impressed with what you guys do. But for anyone at home, if you need any engineering done, JU Designs, that's the place to be.
Oh, thanks.
All right, so, but yeah, we'll let you continue on where you are, and
Sounds good.
we'll give these guys an update a little later.
Perfect. Thank you.